Good morning, everyone. We are back with this yesterday's class. So we covered about the landslide yesterday. Okay, if you go through the video lecture, so that was the first lecture of Unit 5. So it was covering what is a landslide basically, and some important terms and some important definitions related to a landslide. And then we moved on to some activities, the types of activities within a landslide. Okay, so I guess I have also provided the notes for that explanation, so do study from that notes and follow the lecture. If you have any doubts, you can ask me. Okay, so today this is the second lecture, video lecture of this unit 5. Okay, so we will be starting with the causes of landslides, and then we will move to the different types and of landslides, or we can say the different movements in a landslide, different movements of a landslide rather. Okay, so we'll start. So today we'll be covering only two, that is your slides and falls, and the rest three types we'll be covering in the coming classes. Okay, so we'll start. All right, so there are different causes of landslides. Okay, or you can also sometimes say call them as initiators. Okay, I have also told you about the initiators. Okay, so first cause of landslide is geological weak material. Okay, that means your earth, okay, the soil, okay, or the rock mass on which there is there are chances of occurrence of a landslide, that is weak. Okay, that is not having greater shear strength. So that material or that soil, that rock mass can fail. Okay, so that is one of the causes of a landslide, when you have a weak material. Okay, second is your erosion. So because of soil erosion, okay, because of cutting down of trees, or because of erosion by rivers and many other factors, okay, and this erosion will lead to your landslide. Okay, so this is the second cause. Then third will be your intense rainfall. Yes, obviously, if there is heavy rainfall, if there are thunder bursts, cloud burst, and there is heavy rainfall throughout the year, or but in a particular day or in a particular week there is heavy rainfall, so that will lead to your landslides, obviously, because rainfall will bring in moisture into the soil, and that will obviously uh, lessen the strength between the particles of the soil. Okay, then fourth one is human excavation. Obviously, by human activities, human excavation. Yes, right. So let's say we want to construct a tunnel through a hill. Okay, so then we will excavate, and we will use, maybe we'll use some machinery to cut the rocks, or sometimes dynamites are used. Okay, so that will again create shock waves through the soil mass. Okay, and that will liquefy the, so liquefaction of soil will take place. So these are the different things that can happen, so that will again lead to your landslide problem. Okay, so human excavation, or rather human activities also will lead to a landslide. Okay, then earthquake. Okay, so earthquake, obviously, whenever there is an earthquake, okay, the ground shakes. Okay, so because of that ground shaking, the soil, the shear strength between the particles of the soil, it decreases. Obviously, there is shaking, and then the particular soil mass or particular rock mass can fail. Okay, so because of earthquake also there can be landslide. Earthquake is one of the very important initiator of a landslide. Okay, and then last is your volcanic eruptions. Okay, obviously, because of volcanic eruptions also, so volcanic eruptions can bring earthquakes. Okay, volcanic eruptions can bring earthquakes, and then because of volcanic eruptions also there can be landslides. Okay, if a volcanic eruption is bringing in earthquake, obviously there will be a landslide. And if it does not bring an earthquake, let's say, but then also, because hot molten lava is flowing through the soil, right? So because of that also the soil mass can lose its property, okay, lose its property and strength. That can also lead to your landslide. So these are the most important causes of a landslide. Okay, so we'll move on to the next topic. Okay, so this is the types of landslides. Okay, types of landslides, it is classified based on slope movements, okay, by Warnes, okay, in the year 1978. Okay, so it's still being followed now also. Okay, so this is classification based on the type of the movement. Okay, and most importantly, if we say about what are the different types of landslides, most importantly these things only we study. Okay, yes, there are obviously there are different types of landslide. Like we studied yesterday, what is an active landslide, right? What is a relic landslide, what is an inactive landslide? Okay, that is also there, that is based on the activity. Okay, but here we are studying based on the movement. Okay, the movement of the soil mass that has failed, or the rock mass that has failed. Okay, so these are the different types. Falls. Okay, so you have again under falls you have different types of falls. Okay, that is based upon the material. Okay, based upon the type of material. Okay, if your material is rock, then that fall will be called as rock fall. Okay, then if it is comprising of debris means broken pieces of concrete, then even broken pieces of rocks. Okay, then even that can be your anything. Okay, debris can be anything which is coming out from a particular place. Okay, so there can be debris fall also. Mainly it is debris means mainly it is scattered pieces, okay, of rubbish or remains. Okay, then there is earth fall. If the fall is comprising mostly of earth, then it will be called as earth fall. Okay, like that you have topples, rock topple, debris topple, and earth topple. Slides. Okay, slides you have two types: rotational slide and translational slide. Then under this also you have rock slide, debris slide, and earth slide. Like that you have lateral spreads and flows, and then you have complex is combination of two or more, at least minimum two you must have, or two or more principles of types of movement. Like if falls and topples are taking place together, then that will be called as a complex landslide. Okay, okay, I hope it is clear to you. So let's move on. So today in this class we'll be covering the slides. Okay, the slides we will cover today, and then we will cover the falls. Okay, all right, so moving on. Slides. All right, so there are how many types of slides? So there are two types of slides. Okay, so see, whenever I'm explaining something, okay, you always keep this your you can always pause the video. Okay, whenever you need any information from the previous slides, okay, like this, so you can always pause the video and you can go to the slide. Okay, all right, so we'll move to the slides. So how many types of slides are there? There are two types of slides. Okay, there are two types of slides. One is your rotational slide, and next is your translational or planar slide. Next is your translational or planar. Okay, planar slide. Okay, all right, so what is a slide? Basically it is a slide is a downslope movement. Okay, if I write slide, okay, what is a slide? It is a downslope movement. Okay, so it is downslope movement of material, that occurs along a distinctive surface. Okay, downslope movement of material that occurs along a distinctive, okay, distinctive surface. Okay, now what is distinctive surface? Okay, here in this particular landslide, the distinctive surface can be of two types. Okay, in this particular type of landslide, distinctive surface can be of two types. Okay, so what are those distinctive surface? One distinctive surface is your curved surface, curved, and second distinctive surface is your planar. Okay, so there can be two distinctive surface in this type of landslide. So one distinctive surface will be your curved distinctive surface, and second will be your planar. So based on this distinctive surface only, your slide type of landslide is bifurcated. Okay, if your distinctive surface is curved, then it will be rotational slide. Okay, so here the distinctive surface is the surface of failure or surface of rupture. Okay, so in this case, if distinctive surface is curved, it will be rotational. Okay, and if it is planar, it will be translational. That is why translational slide is also called as planar slide. Okay, I hope this is clear to you. All right, okay, so I think we can move to the next topic. Okay, so once more, rotational slide is one in which the surface of rupture is curved. Okay, and in translational slide the surface of rupture is planar. All right, okay, so see, this is an example for you. If I take a chocolate, okay, if we take two chocolates, okay, like in this example, this is one layer of chocolate and this is another layer of chocolate. Okay, and then if we heat or if we just warm them, what will happen? They will start melting. Okay, so in this case, the top layer of chocolate will try to slide down the it will try to slide down. Okay, because of melting. So this sliding, okay, this action of sliding, you can similarly explain in the landslide, which is showing the movement of slide. So we are studying the slide type of landslide. Okay, this is the landslide where the movement of the landslide is sliding. Okay, so one best example is this. Okay, two chocolate layers. Okay, and if we are heating this chocolate, then the top surface may slide. Okay, so in this type of landslide also similar things happen. Okay, the failed material, so in this case this top surface is the failed material or the failed chocolate, so this will slide over the bottom part. Okay, so this was just an example to show you. All right, so moving on to the next. Okay, so you can see here. Okay, see this. Okay, so this was your original soil. Okay, your soil was like this. Okay, your soil was like this. Okay, this was original soil, but because of an initiator, okay, you have studied about the causes, those are initiators. Because let's say because of a heavy rainfall or because of an earthquake, the soil mass has now started to fail. Okay, so there is a landslide developed. Okay, now this is an example of your landslide which is showing slide type of movement. Okay, so in rotational slide, this is the distinctive surface. Okay, this is the surface of rupture. Okay, so this is the surface of rupture. So in rotational slide, you can see the surface is concave. Okay, it is curved and it is concave upwards. Okay, it is concave upwards, not downwards. Downwards concave will be like this. Okay, so it is not downward. Okay, it is concave upwards like a spoon. Okay, this is this shape is looking like a spoon, right? So in rotational slide, the distinctive surface or surface of rupture is your concave upwards. Okay, but see, in your translational slide, also called as planar slide. Okay, this is also called as planar slide. Here you see the surface of rupture is plane, or it is flat, almost flat. Okay, this was the original position. Okay, then the mass, soil of mass, it failed. Okay, so this is the failed soil of mass, but the surface of rupture is still planar. Okay, so this is what translational slide is. Okay, so moving on. Yes, so sometimes what may happen is that in rotational slide. Okay, so now we are going into what is a rotational slide. Okay, so sometimes what may happen is that in a rotational slide there can be multiple curved surfaces. Okay, in a rotational slide there can be multiple curved surfaces. Okay, so if in a rotational slide there is multiple curved surfaces, okay, for example, you take this example, multiple rotational slide. Okay, so, see in this example, or in this type of rotational slide, see there are multiple curved surfaces. Okay, so the soil mass has failed at different points. Okay, so in this case what happened, okay, each failed mass or the failed block is called as a slump. Okay, what is a slump? See, I'll just tell you. In a rotational slide which is having one or more curved surfaces, okay, and then the movement of the material will be incomplete, because see, let's say if this surface is failing, okay, that will means it will move down, but again in front of this surface there will be another surface which is also failing. So what will happen, the movement of this layer will be obstructed by by this layer. Okay, so what will happen, hence this layers, okay, the first layer's movement will be incomplete. Okay, because there is second layer. Now this layer will also try to move down, and then again there will be another layer, okay, which is also failing. So what will happen, the movement of this layer will also be incomplete, because there is one more layer which is failing in front of this layer. Okay, so in this case this type of landslide is called multiple rotational landslide. Okay, and then the blocks that is left, okay, I'll show you, let me clear this part. Okay, the blocks that are formed, okay, so each block will be called, or is called, as a slump. Okay, so you can see in this figure there are different blocks that are formed. Okay, so this is your block number 1. Wait, so this is your block number 1, this is your block number 2, this is your block number 3, this is your block number 4. Okay, so there are different layers of blocks. Okay, so there are different blocks formed. So these blocks are called as slump. Okay, slump. Okay, all right, so this is a multiple rotational landslide. In one single landslide multiple number of curved surfaces can be observed. Okay, then there is second type, that is your single rotational slide. So obviously by the word single you are able to understand only one curved surface will be there. Okay, or only one surface of rupture will be there. Okay, so this is your single rotational slide. All right, and last is your successive rotational slide. Okay, all right, so I think this figure diagram is repeated. Okay, so I will see, I'll check. Okay, there may be some mistake here. Okay, so I'll put the mistake, or I'll see whenever there is a mistake in a video, whenever there is a mistake in a photo, so you always check your description. Okay, in the video that I will upload, you always check the description of the video. If there are any corrections to be made, I will write in the description. Okay, and then the corrected photo of that particular slide or the particular presentation I will send you in your class notes. Okay, so I'll check about this. Okay, anyways, so successive rotational slide, just like a multiple rotational slide. So what happens, yesterday I studied about this successive and in sequence. Okay, so if you remember yesterday's activity of a landslide, that part you see successive and sequence. Okay, there were two different types of landslide where that was mentioned. Okay, so successive means what? In succession. Okay, in succession, there will be, wait, let me clear this. So in succession there will be your surface of failure generated in a landslide. Okay, so that the landslide which is having that successive formation of your surface of failures, then that landslide will be called as, or rather then that rotational landslide will be called as successive rotational landslide. Okay, where the surface of failure will be in succession. Okay, one after the other. Okay, so in this case actually i'll I'll give you, okay, I'll give you the this photo properly in your class notes. Okay, or in your study material, but just remember the surface of failure in a successive rotational slide uh, is always present in succession right after the other. Okay, all right, so you can pause the video if you want, you can go through it once. Okay, okay, so we're moving on to the next topic. So this is an example of a rotational landslide. Okay, at Holbeck Hall in North Yorkshire. Okay, at Holbeck Hall, North Yorkshire. Okay, see, you can see. See, sometimes, yes. One more thing I want to tell you. Okay, please note it down. So, a slide. Okay, let's say this landslide has occurred here. Okay, so initial landslide was initial movement of the landslide was sliding type of movement. Okay, but throughout that landslide, that sliding may not exist. Okay, so sometimes what happen, a landslide can start with a sliding movement but can end up with a flowing movement. Okay, so that means complex landslide. Okay, so that means what, see in the previous figures. Okay, see complex, in this complex you see combination of two or more physical types of principles, right? So sometimes what may happen, a particular landslide can take place because of a particular movement. Let's say in this example, this landslide took place because of the sliding. What type of sliding? The rotational sliding. But what happened once the landslide started, or once the landslide is initiated, okay, it is the mass is failing, then at some moment, okay, at some point, now your flow can takes place. Okay, so in this particular example, though it started with a sliding movement, but till the foot and toe of the landslide, the landslide resulted in the earth flow. Okay, sorry, mud flow. Okay, okay, just a moment. Yes, the slide, it ended up with a mud flow. Okay, so then there can be combination also. Okay, so it is not necessary that always one landslide will take place and that movement will remain throughout the landslide. No. Okay, so there can be multiple movements. So in this example, okay, this is a real life example at North Yorkshire. Okay, so in this example, in this type of landslide, what happened, it started with a sliding movement but it ended with a flow movement, or rather mud flow movement. Okay, so this was your mud flow. Okay, but started with a rotational slide. Okay, so started with a sliding movement. All right, okay, so move on to the next topic. Okay, I hope it is clear to you. Okay, all right, so this is just another picture that I wanted to show you. Okay, see, rotational slide, surface of rupture, concave upwards like a spoon, translational slide, surface of rupture, planar. Okay, all right, okay, so this is an example of your translational slide. Okay, so this is a translational slide. So you can see, okay, where this slide took place. This slide took place in Niffen Bay. Okay, so shallow failures in the cliff top. So you can see, okay, so and now also you can see where is the crown, okay, which part is the crown. Obviously crown is the practically, okay, so this part is the crown, practically undisplaced, okay, practically undisplaced part is the crown, okay. So what is this, okay, where is the head, where is the major scarp, minor scarp, okay. So all these things you can easily identify from this, okay. So this is an example of a translational slide, okay, real life example. You can go through, okay, for some seconds, then I will move to the next topic, okay. All right, okay, so we move to the next topic. So now we'll study about falls, okay. So what are the different types of falls? So what is a fall actually, okay, so that you have to be you have to be clear with, okay. So what is a fall? A fall is a landslide which involves the collapse of material from a cliff or a steep slope, okay. So collapse of materials, collapse of material from a cliff, from a cliff, from a cliff or steep slope, okay, or steep slope, all right, sorry, okay. So also it involves a mix of free fall through air, bouncing and rolling, okay, involves mix of free fall, okay, it involves mix of free fall through air, comma, bouncing and rolling, okay. And this type of landslide results in collection of rock or debris near the base of the slope, always remember, okay. So this type of landslide will result in collection of debris, collection of debris, collection of debris near the base, near the base of the slope, okay. So you will know, you will understand what is this collection of debris. I'll explain in figures, then it will be clear to you, okay. And debris cone, okay, so we call this as a debris cone. A debris cone is obtained, debris cone. So what is a debris cone? A debris cone is debris deposited in conical shape with a surface slope greater than 10 degrees, okay. So what is a debris cone? It is debris deposited, debris deposited in conical shape, in conical shape with surface slope greater than 10 degrees, okay. You can write it down. Debris deposited in conical shape with surface slope greater than 10 degrees, okay. So that is called as debris cone, okay. So a debris cone is generally formed in this type of landslide, okay. So we'll move on, okay. Also see in your notes you can you will find that a fall is a abrupt movement, okay, of masses of geological materials such as rock boulders that become detached. Okay, so that definition also you can write, okay, along with this definition. Okay, that definition in your notes, that also you can write along with this definition. Okay, okay, you can combine these things. So always remember, class notes and your provided this study material that I have provided, you combine and you write, or you make your own sentences and then you write in your exam, so that will be better. So okay, you always combine. So you both class notes or video lecture, and then you combine that with your study material that will be provided to you. Okay, then your preparation will be complete. Okay, all right. So then there are different types. Okay, so these are different types of your falls. Okay, so this is your rock fall, this is your rock fall. Okay, this is your earth fall, and this is your debris fall. Okay, so this is, you have already seen the Warn's table. Okay, so you have seen the Warn's table. Let me tell you. Okay, so see, you can see the Warn's table. Okay, so by Warn's table, so falls, see rock fall, debris fall, and earth fall. So there are different, these are the different types of falls. Okay, that will be, that you will observe. Okay, rock fall, debris fall, and your earth fall. Okay, this is your rock fall, this is your earth fall, and this is your debris fall. So in each type you will see collection of material that is formed at the base. Okay, formed at the base of the slope. Okay, so this, some collected material is formed here. Also see, some collected material is fall. Okay, so this is called as debris cone. Okay, so this is called as debris cone. But what about the rock fall? Okay, in rock fall you see it is not called as debris cone. Okay, here you see it is debris cone. Okay, this is earth fall, the debris that is formed is called as debris cone. In debris fall also, this cone that is formed is debris cone. But what about the rock fall? Okay, so there is a particular term for that. Okay, that is called as talus cone. So I'll tell you what talus cone is. Okay, so I'll just show an example, then I will make it clear. Okay, all right, see, this is an example, this is an example of rock fall. Okay, so this is an example of rock fall at Pennington Point. Okay, so it's an abrupt motion. Okay, so suddenly what happens, see, the this area, okay, this is this is the mountain, okay, having rocks. Okay, it's composed of rocks. Suddenly what happens, there is an failure. Okay, there is a failure, means because of weathering, because of maybe rainfall, earthquake, or different, or any type of activity, there is a failure. So suddenly what happens, in the second picture you can see that same. Okay, at the Pennington Point, what is happening, the rock is collapsing. Okay, the mass, this mass is collapsing, means this is failed. Okay, and what will happen, you can see in the first picture there was nothing here. In second picture, a cone shape of a cone shaped structure of the failed rock mass is formed. Okay, see, you can easily observe that if you see properly. Okay, so this is a real life example of a rock fall. Okay, so this is an abrupt motion. Okay, so see, so this was a photo that was taken a week before the landslide. Okay, so nothing. Okay, so it's completely clean. So what happened, and this was the photo after the rockfall has occurred, same place, same position, but here you can see there is a this cone develop. Okay, see, you can see the cone, it is easily visible. So in falls generally you will see a cone. Okay, so for a rock fall this is called as talus cone, and for debris or earth fall this is called as debris cone. Okay, so you can see this thing. All right, okay, so this is same, this is the example of this Pennington rockfall. Okay, so this was a closer view. Okay, so if you observe from a distance, so This is the same example. Okay, this is rockfall at Pennington Point. Okay, all right. Yes, see, you can see this is a talus cone. Okay, this is a talus cone. Okay, so this is in the shape of a cone. Okay, so a talus cone is formed. Okay, so whenever there is a rock fall, you can see, you will see a talus cone. Okay, so this is a talus cone. All right. Okay. Okay, all right. Yes, so your homework for today. Okay, so this is the this was the that was the final topic for this lecture. Okay, so in the next class we will cover the remaining three types of landslides. Okay, so that is your flows and your spreads and topples. Okay, so you have a homework for today. So you try to in Google, you go to Google and then you search and then you study about what is talus cone. Okay, what actually is talus cone, so you will get an idea. So this is your homework, okay, for today. Okay, so in the next class, so it will just take like 10 to 20 minutes. So you go through Google and then you note down in your copies. Okay, and then you can send pictures also. Okay, in our WhatsApp concern group. Okay, you can write it down in a copy and you can take photos and then you can send in the concern group about what is talus cone. So this is a homework for you. Okay, so write it down in your copies, okay, or in a piece of paper. Okay, or and you can send photos. Okay, so what is talus cone? All right, so I have already explained what is debris cone, so you need to find what is talus cone and is there any relation. Okay, so that is not necessary, relationship is not necessary. So what is talus cone, you find it out. Okay, and the next class we'll study about flows. Okay, then spreads and then topples. Okay, so with that said, thank you everyone for joining into this class and for looking for joining into this class and for giving your time. Okay, so we are all we should not miss our classes, we should not get hampered because of this, we should always study. Okay, so this was a small initiative taken so that your study is on par with the syllabus. Okay, on par with time also. Okay, as and on par with the planning that is being done. Okay, so with that said, thank you for joining the lecture, and then I'm hoping to meet you in the next class. Okay, so regarding the notes of today's lecture, so first you all go through the lectures. Okay, you study the lectures, you attend these video lectures, and then we will the notes, regarding the notes, I'll hand it when the college opens. Okay, so during this time you follow your lectures properly. Okay, so everyone should study and you follow your lectures. Whenever there is a mistake, okay, I will write down the mistake in the description section of the particular video. Okay, if any, and also in comment section you can write if there is a mistake. Okay, because these videos we don't pause in between, so we don't have time to edit the videos, so that is why. All right, and then you can pause the video in between if you need to write note something down in your copies. You can pause the video and you can write it down. Okay, so anyways, thank you students, have a nice day ahead.